that we're able to get a lot of these things in. So we're going to start off on some new solver supports. So these are things that have kind of been requested from the field. We've enabled the connector ribbon and the connector technology for 2 new solver profiles, one being Exodus or Sierra, with a couple of very basic realizations, so a rigid length, spring, rod, and bar. For those realizations, we have enabled the same infrastructure that we enabled for 2022.0, so we should be automatically creating properties and materials for those realizations. So there should be no need from a customer point of view for them to have to create properties or materials for those realizations. And more excitingly is there's been some benchmarking going on in the background, and there's been a lot of work from various teams going on in the background. And we've turned on connectors for FECO based on some studies showing that actually we can use connector technology for FECO. So as a part of that, we've enabled the part hierarchy on solver deck export and import to ensure that your connectors are still joining to the right things. And we've enabled a very simple first step from a realization point of view, which is the bar 2 realization. That doesn't mean you can't use other realizations. So if you have a request for any specific types of realizations, so like hexes with imprints and that sort of stuff, we can facilitate those. It was just the first step was turning on the ribbon, enabling the technology and ensuring that import, export, and link and solver deck was managed and works. So that's quite an exciting sort of introduction from that side. The next thing that we've been kind of busily working our way through is the PostScript removal project. This has been a long, on-standing, almost 1.5-year project from everybody, where we've been really focused on trying to work out from a legacy perspective what all of our internal PostScripts on all of our realizations were doing, categorize those, and then work through the process of working out and creating general infrastructure to allow us to facilitate turning these off. So what this means from what this means is we've gone through the process of deprecating 35 PostScripts that covers around 90 different connector realizations over 7 different user profiles. So it's quite a big impact for 2022.1. What you should see on creation or loading of any historical deck, the model will still behave as it always will. It will still be pointing to the PostScripts for the moment. So if you import a legacy deck, you import a binary, nothing will change. Everything will work as you expect it to do. There will be no change from that perspective. Any connectors created new will then be using this new infrastructure. Any connectors being FE absorbed will now use this new infrastructure. Going forward, we are going to turn off. So for 2020, hopefully 2022.2, hopefully, importing a solver deck or importing a HM binary file will now no longer use those PostScripts at all. So this is the start of the transition phase from the legacy style used with the PostScripts to no PostScripts at all. So the way we've had to do this is we've introduced a wide-ranging levels of infrastructure in the background from a connector point of view to facilitate this happening. So things like enabling the ability to turn on diameters for different realizations, enabling the customers to choose how they want their element realizations to be organized. Contact historically has been done through PostScripts. They are now done internally. We've seen significant improvement in realization times, and I'll get to all of these with metrics in a minute. Things like systems and vectors that are automatically created as a part of the realization are now automatically assigned. And the assignment historically was done through the PostScript. We offer the ability to push a specific name from the user perspective to the property material, so you can have 2 controls with the same definition, with 2 different names, and all the properties and materials be derivatized by those names. Again, so you could have 2 ACM generals, one being called Spot and one called Rivet. And then from a customer perspective, they can go in and tune the different materials of those to be whatever they particularly want that to be. And the last point here is the absorption. It will no longer point to the PostScripts, as I said earlier. So what does this mean for performance? There's been a significant piece of work in the background from a performance point of view. Now, this is a logarithmic scale. This is not a linear scale. This is a logarithmic scale. So for reference, 100 seconds is about 1.5 minutes. 1,000 seconds is about 16 minutes. So you can see here we've gone for some of these realizations, we've dropped from somewhere around half an hour for 4,500 connectors to a couple of minutes. Some even more. So it's on some of these single 1D realizations, we're seeing some improvement in time. Not significant, but it's gone from around 10 seconds to under 10 seconds. And you can see with some of these hexa ones, we're seeing, again, a significant step difference between these. So there's from a performance perspective, you should see all realizations that historically had used PostScripts to be significantly faster. So that's a big win from that perspective. The next thing is not only is it going to be faster for a customer perspective, so that's great, they actually have more control about what happens and what that means. So I said historically contacts used to be created within the PostScripts. We can now define as a part of the FE configuration file you can specify that you want contacts created. And if you specify you want contacts created, you then have these dialogues appear in your control or in your connectors where you can specify explicitly how you want the contact created. So single contact per link pairing. So you've got those different methodologies for contact creation. Specifically for LS Dyna, because it was the only one that was appropriate, but we've got the ability now, you can specify whether it's a node to surface type, surface to surface, or contact spot weld type. So you can actually control the contact card for your contacts being created. Now, there are some exceptions to this for some of the realizations where we've created before this infrastructure that are still on slightly older infrastructures. So things like Hexa Nugget, you won't have this yet. We are going to migrate all of sort of the intermediate realizations that were kind of created in the interim between PostScripts and now. We're going to try and migrate as much of this logic to the new infrastructure, so everything should be on the same level. So for the moment, they're not. But going forward, they will be. So going forward, you should be able to see these card images appear for LS Dyna for some of these different realization types. We've added the ability to organize the realizations. So historically, a lot of the explicit analysis split their realizations by link pair. So link 1, link 2, link 3, link 4. So there was a component that held between link 1 and link 2, and a component that held the information between link 2 and link 3 and that sort of thing. So that's now enabled. We've got single, which is our standard. So all realizations of that type are organized into a particular include or subsystem. And then we have per connector in the situations that we've seen from some customers where they want their realizations organized on a per connector basis. We have the option to organize the realizations on a per connector basis. And again, all of this has come from historically what the PostScripts are doing. Now the customers have the ability to actually interactively change these according to what they want it to do. The one exception to this will be Abacus fastener, because the fast definitions of the way the fastener works, they all need to be organized per link pair. So that it's set as the default, but if you change it, it's still going to work as the default. It's how it needs to work for the realization to be valid. So there are a couple of small steps in here just to make sure that the customers get the right valid realization rather than some other selection or option. But again, these are things that we saw historically in the PostScripts that have now been migrated from that perspective. And the last one is the diameter, the ability to define the diameter on some of these realizations. Again, some of the realizations, so historically the bolt C-bar would define a diameter for the minimum width hole in the stack up and apply that to the property. That is now being generalized to any realization, including the use of attachments. So if you use attachments and you try to join those together, we'll try and find the minimum hole size and apply that to the property so you have the diameter set on your property cards for those. For spots, lines, and areas of any type, any element type that is rod, bar, or beam, this includes C-bar rigid, MAT 100, MAT 196, abacus fasteners, C-welds. We now have the option to explicitly define a diameter. So you can, historically, that was set within an internal sort of table looking up the thicknesses. You can directly use the diameter thickness mapping table that we have now, and you can have a bit more control about what those diameters will be. So historically, that wasn't something that was available to the customers. So that's now upfront, so the customers can do whatever it is that they want to make sure that they get the realizations that they're happy with. The other thing to mention in here is on realization, we assign the property back onto the connector. So if you unrealize the connector and realize the connector, you get exactly the same property. The only thing we do in that case is we gray out the diameter for some of these realizations because the information is actually pertinent to the property. So the property contains the diameter, the input value from here is no longer relevant. So again, just something to bear in mind. But this was done to ensure that on realization, unrealization, the customer gets consistency in terms of their realizations. So consistency is really what we're driving for here, and efficiency. So that's kind of the overview from the PostScript removal project. I think we are left with 3 PostScripts that are currently yet to be migrated due to various reasons, but they are nominally in PAMCrash and ANSYS, and I think there is one in LS-DYNA. So if you're using any of those solver profiles, you might encounter 1 or 2 that contains PostScript. Going forward from here, the next steps for these projects, so for future development, is going to be removal of is enabling customers to run a script at the end of the this post-factory run. So the intention there is that they can leverage the full infrastructure and then do any customization at the end of that on any realization that they want. Currently, that's not enabled. So currently you have to choose between a script that does everything or our realization infrastructure that does everything. There's no sort of 2 ways, and we're going to be introducing sort of a hybrid working method in the future. So that should be coming soon. The next one is something really exciting. So this is something that's kind of been often requested from customers, especially those coming in using the part hierarchy and part structures, is generating connectors from solids, and then also leveraging as much of the information that has come in from the parts as possible. So the first thing is we've added solids as a selectable to the context, to the fastener point and line context. If you're in the line context, we perform a midline extraction before converting them to connectors. So if you so you just need to make sure that the midline extraction process can actually process that particular solid to get a meaningful connector out of it. If you do encounter any issues, please raise tickets and we can try and make sure that we can get these addressed as soon as possible. So onto a demo. So this is a short video where I've got a Venza model, I believe, and I've split it down into a series of spots. So these are all solid geometry. So I'm selecting all of these solids. I'm going through the process of creating a control. Now there's a minor bug with this video where the control isn't selected back. That has been corrected. So on close of the control manager, it should select the control automatically for you. And then it's just a matter of selecting the control and realizing. So it just goes through the process of realization now. So it's 5,000 spot welds automatically converted at the centroid of the geometry. And then this is the same process, just showing the line abstraction process as well. So in this case, I can select a series of solids. We do the midline extraction of those solids to make sure that to find the path of the connector. Again, going through the process of selecting a control. In this case, I'm defining a control. Select the control type. Again, that's automatic in dot 1, and then it's just the realization from here. So it's quite a direct method now, especially if your part structure, what's coming in from your CAD tree, contains solid geometry representing your connectors. It's a really kind of a final kind of step of the workflow that has been missing for quite some time. What we don't do at the moment that we are looking for sort of in a future perspective is abstraction of metadata from the geometry. So trying to find diameters from the bolt size and that sort of thing. That's something that's in the plans for the future, but we currently don't do that. What we do, however, is abstraction from the part. So if your part contains metadata from the CAD, so that any descriptors on the part itself, we can extract those descriptors on the part entity itself and apply those to the connector. We also have a mechanism to allow the customers to have their custom metadata mapping as well. So if you have any metadata that sits on the part that doesn't meet sort of these labels in here, you can describe a small file and then point it to it in your preferences, and that's considered as well during the mapping. So I know from some geometries that we've seen, there's quite complex metadata being embedded, especially from the aerospace perspective. This can help facilitate that process. So what does that look like in action? In this case here, I've got a particular solid geometry. If I scroll down, it tells me connected part 1 and connected part 2. It tells me the connector type, and it can tells me the ISO process type or the connection methodology. So in this case, I know that the connected part 1 and 2 are pointing to UIDs. So I can go into my hamburger menu. I can click on extract metadata from part. I know I'm looking for the UID. I know I'm looking for an exact match. I can select the solid. In the process of creating the connector, we're abstracting the geometry and the metadata. So in this case, we've got link 1, link 2, and that's come from the part. Scrolling down in the metadata, it contains that it's a spot weld type and it's a resistant type spot weld. So this really covers use cases when you're reading in metadata from, you're reading in part structures, or you've got CAD that contains metadata on the part, and you want to try and leverage this for connector if that metadata is robust and quite usable, then this is the kind of the approach that we've embedded to allow you to facilitate those workflows. And the final thing that kind of fits into the part hierarchy and the part structure workflow is the organization by part. So we've added a new method in the auto organize or reorganize settings to reorganizing a connector back into its base part. What this does require is it requires the geometry that the connector was created from to be present in the model, just so we know what the hierarchy of that geometry is. But what this does is it enables the leverage of the part hierarchy, instancing, revisions, and representation management if you want to make sure that your connectors go back into the right part in the part hierarchy and are organized correctly in the part tree and all of that sort of great stuff. So this is a methodology to facilitate you, again, ensuring you can leverage the part tree in the simplest way possible. So what this looks like in this particular case, if I go back in, I'm going to create a connector from a solid. I think I'm going to use the same solid we used before. At this point, I'm not extracting any metadata, I'm just creating the connector. If I go now into the part hierarchy, or I go into the connector, sorry, I'm going to reorganize this back into its base part. So it's created one connector group. If I go back into the part and we click on the part itself, we can see that I have one connect group and a solid geometry. Now, all of these are instances of each other. So I'm going to remove the solid because I'm not interested in the geometric representation anymore. I'm going to save this representation. And then I'm going to instance sync. So what this is going to do is it's going to sync to all instances of that particular solid, the connector. So actually once this is finished, I think it takes a couple of seconds, we can see all the solid geometries disappear for those, and I have connectors at all of those locations. So in the use case where your customer, again, has instances, has parts, has solid representations, it doesn't need to be a solid representation. It could be a line or a spot. or surface, we're able to organize the connector back into those base parts and then leverage the part hierarchy to transfer the connectors to all the locations within the model. From here, you would need to add links to those connectors, and then it's a simple matter of applying controls and realizing. So this is kind of quite a nice mechanism to allow you to leverage the part structure as much as possible. The next one is quite an exciting one. Again, minor change of tack on this one. This is the aerospace realizations. We've been working closely with the aerospace team, trying to port the realizations into core connector tech. So again, what the performance improvements that we were seeing above with the PostScript removal, we're seeing very similar numbers. So there's been a lot of really good work to ensure that we've got quite a quick approach to this. So what we've done is we've enabled Huth and user-defined Huth as a method type in the following realization, so they match what was available within the fastener setup tool. Under method type, you're able to choose Huth or user-defined. You can go through the process there of defining your rotational stiffnesses, your connection type. You can interrogate your coefficients. If you're using Huth user, you can define your own coefficients. And material, either select a material or point to a file or specify the Young's modulus of that particular material. We take care of single and double shear automatically. So if you've got a single or double shear connection, the calculation methodology is worked out for that automatically as well. So again, what this facilitates is it facilitates the use of all of the connector tech that we've just shown. So things like if you are in the aerospace industry and your customers do have metadata describing the material type or metadata describing the diameter of your particular diameter of the particular rivet or something along those lines, we can abstract that to the connector. We can then set up a control that contains for each sort of connection methodology that they're using. And then using the metadata that's on the connector, we can use the attribute tables and column filtering to isolate those connectors and apply those controls and then go through the process there. So it's quite what we're trying to build up here is a really good workflow to go from geometric representation with information to a fully realized model as efficiently and as simply as possible for your customers. So what does this look like in realization, in reality? So here I've got 12,500 connectors. It's a bit excessive, I know, but bear with me. So in this case, we're going to create a new control. I'm going to describe this as a C-bush, RB3 C-bush, RB3 C-bush, RB3, apologies. We see the method type is set to none. I'm going to change that to Huth. I can specify a diameter into here. So if I want a particular diameter, I can select a material or I can enter Young's modulus. So I'm going to enter an E value. So I'm going to make them steel. I'm going to change it to rivet type. And that is, if that's where I'm happy with that. And then user defined Huth, you can see that we've got the different coefficients there as well. Change that back to Huth. And then I think I rename from here. No, I don't rename. So I close the control, you can see the controls automatically selected, and then I realize from here. So this is 12,500 connectors being applied with Huth calculation. Now, historically, we were seeing this take anywhere up to 15 to 20 minutes. Timings on this is live, and it's roughly a minute. So again, a significant improvement has come in from a performance perspective in here. Now there's one thing that is yet to do, and that is there's a particular star configuration that we're yet to implement, but from a basic implementation, that's where we are. And if I select one of these and isolate and do a fit, and I look at the properties of those, you can see the properties are calculated based on all of the good things that the Huth and Huth user are based off. So it's from an aerospace implementation point of view for Huth and Huth user, where this is kind of the step to transitioning the aero workflows into the core connector technology. The next thing we've done as a part of the aerospace realization, again, following the post-strip removal project, we've looked at HyperWorks, so the Rutman type connection. We've gone through the process here of removing the post-strip for that as well. Everything else within that realization remains unchanged. You'll just see a significant performance improvement on the realization timings with this. The method type in this case is uneditable and set as Rutman. So it's relatively clear to the customer as to what that actually is doing and what that means. We've added a new attachment type that's been done to replace the stuck node tool. So the stuck node tool is again another one of the aerospace tools that was prioritized on discussion with the PM team. So we've added a new methodology within attachment. You change the element type to RB3 stuck node, and then you're able to generate effectively the same thing that you were seeing within the stuck node tool within the aerospace ribbon. So again, this is just a migration perspective. The next big thing, there's many big things. The next big thing is the seam chord improvements. So this has been requested from the heavy industry area. So this is something that sort of we can jump into now. We've added the option to now allow tri-elements into the weld or the heat affected zone. This is an important addition as an optional addition, especially in quite tight curvature and corners. We were seeing some poor element quality. So this is to help improve the element quality through here. And again, it's an option that the users can turn on or off as they see fit. The next option that we've added is it's what we've called the extension angle. So it allows the continuation of the part to be considered from a projection methodology rather than dropping an angle straight down. At the end of the part, we consider the continuation and then calculate the angle based off the continuation of that part. So it's so in this case, it's quite a straightforward thing, but it should result in some improved quality from that perspective and options if the customer is requesting it. Now, this is explicitly only allowed for T-welds, and you can tune the extension angle as you see fit to meet the requirements of what you want. The next thing we've done is we've enabled a series of new realization styles for seam chord LTB. So what this looks like is we've double-sided welds. So now we have angled double-sided welds in here. Historically, we've only been single-sided. We've got, so that's two angle sides. We've added vertical edge and double angled. So in this case, the bottom edge is disconnected from the other two. So all three are imprinted. We've got, again, this is a very vertical edge and angled doubled. So this is again very similar, but it's single-sided, where we've got an imprint, lower section of the weld and upper section of the weld, which can have different definitions defined. And then we've got vertical edge and angled. So again, very similar type of realization, but they all converge at the single point. This is kind of, again, on the request from a heavy industry perspective, where we've seen a lot of customers ask for double-sided welds, but also double-sided welds where they're not connected, where they're sort of one's off the edge and the other is projected into the plate. So this facilitates that realization styles. The next is the absorb enhancements. So there's been some work from the absorption side, where historically we could only absorb a certain subset of our realizations due to complexity reasons. And the same thing can be said for, we were only able to absorb realizations that we knew about. So this has been some work to be able to absorb custom configurations according to the configuration in the FE config file. So if you describe a structure within the FE configuration file, we should be able to absorb that we aren't able to process homemade postscripts to work out what the realization is doing, and I think that's relatively reasonable. But the rest of the realization, we are able to reconstruct. So if you have custom realizations from your customers, we should be able to absorb those now through this. Cylinder bolts has always been something that we haven't been able to absorb historically. That has now been corrected. So if you're using or you have cylinder bolts within your model, we are able to identify and absorb those. 1D absorption has been added to lines and areas. These are only for mesh dependent realizations at the moment. We do have tickets to allow us to do contact based realizations as well, but currently these are only mesh dependent realizations. So for use cases where you have mesh independent realizations, you still might have to go through the spot panel, combine them as a spot line, and then convert those spot lines into line connectors. There is a workflow for there. It's not fantastic, but there is a way to kind of transition between the two. So this is where we currently sit at the moment. So again, this is a long-standing request that we've seen from that was never historically supported, but we've kind of really worked really hard to get this in. The next big thing is the group link enhancements. So group links were introduced a fair few years ago as a mechanism for grouping different parts or different sides of a realization. So in the situation where you're gluing a front windscreen to a body in white, your windscreen would historically be one link, and then you'd have to add each of those other links independently and then group them together into a single link. We've now tried to make that a lot simpler and a lot more straightforward, so you can actually automatically group those. We can automatically group those for you if the number of links is set to 2. So you've got auto grouping of links for 2T connectors for spots and lines. We've got the ability for absorption can be performed ignoring the links. So again, in the use case for a tailgate seal, for example, where you've got, again, many components on one, or many parts on one side and many parts on the other side, or a single part, but many components on the other side, depending on how it's been modeled. Historically, the combine mechanism would only look for like links. This has now been removed, so you can go, okay, I don't necessarily care what the links are. I just want to combine over the seal effectively. So this is now a really quite a nice methodology now for going from over many components on either side, but you know it's a continuous weld or a continuous seam or a continuous connector. And we can now absorb group links. So if your realization is connecting to 2 separate parts as a part of one link, we can now absorb that as a group link. Historically, that wasn't possible. So what does this actually look like? So for auto create, within the hamburger, you can see the group link option is set to off. You need to set the value to 2, and then you can enable the group link option. We are looking to try and improve this further, so it can be any number. I select my 2 locations, and you can see 2 groups as 2 links are created. And if I go down, each contains 2 parts. So that's the group link mechanism. Historically, we would have added all 4 links independently, and then you could optionally have grouped it, or you might have ended up with a realization that you hadn't necessarily want at the transition between those different parts. So now it's kind of an automatic process to allow you to kind of step between those as well. The absorb groups. So in this case, I've got a spot weld that's connected to multiple components down here. This one's connected to a single, this one's connected to a single. So on absorption, you can see the last link, link 3, has been automatically converted to a group link. So we've got a group link at the bottom there for those 2 different parts and components. And the last, bit easier to see. So in this case, I've got a steeling profile running between these separate parts. I have the option here for spotline, and then I want to ignore the link information. So in this case, we're ignoring that, and we're kind of absorbing it. So we're going to do the absorption process. And you can see here, it's created a group link for all of the upfront ones. So I have 11 parts in there. If I review that, it's all of the body and white structure. And then the deck lid, obviously, is the single part that the body that seal is connected to, is then on link number 2. And I think that takes me around to covering off what I had in terms of prepared slides. Thanks all.